In order to track the image formed by a spherical mirror, we need to consider three incident rays mainly. And now we are going to see the three rays that can useful to track the image formed by a spherical mirror. And here we have a concave mirror, and here we have a convex mirror. And now the first ray of light we are going to consider is a ray which is parallel to the principal axis. That is the first ray. Incident ray parallel principal axis. So, for a concave mirror, incident ray which is parallel to the principal axis, incident on the mirror, and this ray always reflect back through the principal focus. So, this will be the reflected ray. Any ray of light, any number of ray of light which is parallel to the principal axis will always reflect back through the principal focus, and that is the first ray we are going to consider. And what about for a convex mirror and a ray of light which is parallel to the principal axis? Since it is a diverging mirror, and this ray is definitely reflects and diverge from the mirror. So this reflected ray is not passing through a principal focus. But if we extend this reflected ray in backward direction, and it will pass through a point, and where that point will be the principal focus, the virtual principal focus of the mirror. Then second ray we are going to consider is an incident ray which is passing through the principal focus of the mirror. Consider another incident ray which is passing through the principal focus for a concave mirror. After reflection, the reflected ray will be always parallel to the principal axis. If a ray of light is passing through the principal focus and incident on a mirror, a concave mirror, then that reflected ray will be always parallel to the principal axis. Then for a diverging mirror, then a ray of light which is passing through the principal focus, then it will reflect back and will be always parallel to the principal axis. And now the third ray we are going to consider is, second ray is what? Incident ray passing through principal focus. And third ray we are going to consider is a ray which is passing through the center of curvature. If we consider an incident ray which is passing through the center of curvature, then this is the direction of the incident ray, and the reflected ray will take the same path to reflect back. That means the ray will be reflected back through the same direction. And for a this is how it incident ray, and for a diverging lens also same, it will reflect back through the same path. And then third ray, incident ray passing through center of curvature. And fourth one. If an incident ray is obliquely incident on the pole of the mirror, suppose if an incident ray incident on the P obliquely, or it makes an angle, then it will reflect back, or the ray will be reflected back in such a way that principal axis will act as a normal to the point P, and that will be the fourth ray. And now these are the four rays or incident ray. Now, so by using these, among these four, any two, either a ray which is parallel to the principal axis and a ray which is passing through the principal focus, or a ray which is passing through the center of curvature, or any ray of light which is obliquely incident on the point P, then we can track the image formed by a spherical mirror. And now we are going to see or going to discuss the image formed by a concave mirror and convex mirror separately, and what happens to the image formed by a concave mirror and convex mirror on the basis of the various positions of the object. Now let us discuss how a concave mirror produces image when the object is kept at different positions. And first let us see a concave mirror produces an image of an object when the object is kept at infinity. So this is the pole of the mirror, principal focus, center of curvature, and here the position of the object is at infinity. When an object is kept at infinity, then the incident rays which are coming from an infinitely distant object will be almost parallel to the principal axis. Since the light rays are coming from a far away from the mirror, then the incident rays will be almost equal to the, or almost parallel to the principal axis. So therefore, as we already know, if any number of rays which are coming which are parallel to the principal axis, and how the reflected ray will be. So assume that if it is an infinite object and kept here, okay, or assume that the position of the object is at infinity, okay, and then the rays coming from this object will be parallel to the principal axis. All these incident rays will reflect back through the principal focus like this. So these are the incident rays, and the direction of the reflected rays are like this. So all these rays converge at a point on the principal axis, which is called principal focus. So since all the rays are converge at a point here, so then the image of the object, doesn't matter how big the object is, will be always a point object. Since the image is formed on the same side of the mirror, then it is always a real image, and since it is a real image, then the nature of the image, that will be inverted. Okay, so the image will be real and point size, and it is inverted. A real image is always inverted. So when the object is kept at infinity and it produces a real image which is point is in size, that means very, very small, and it is inverted. So the position of the image is where? At F. And now let's see next. if the object is kept nearby the mirror but beyond C. Suppose this is the size of the image, okay, A, B. So where is the position of the object? The position of the object is beyond C. Then now we are going to consider a ray of light coming from the point B, which is parallel to the principal axis. Okay, this is the incident ray. And how this incident ray is going to reflect? It is going to reflect through the point F. And by this a single ray of light, we cannot determine the position, nature and size of the image produced by a concave mirror. And minimum 2 rays are required. 2 incident rays or reflected rays are required to track the image formed by a concave mirror, minimum. So then we consider the second ray. From the same point B, a ray which is passing through the F. This is the incident ray. And then how it will reflect? It reflects, and the reflected ray is parallel to the principal axis, as we already know. So these 2 cases are definite. Okay, any ray of light which is parallel to the principal axis will reflect back through the point F. And if a incident ray is passing through the principal focus, then the reflected ray will be parallel to the principal axis. So, and where we can get the image? So the image is formed where these 2 reflected rays are intersect each other. Okay, this is the point where these 2 reflected rays intersect each other. Since these 2 incident rays start from the point B, and the point where these 2 incident rays are reflected, and this point will be the same, B. Okay, so this is the point B. That means the point B of the object will be imaged here. And then, so since the position of the object is AB, that means the point A is on the principal axis, and then in the image also this point has to be on the principal axis. So this is the point where the image is formed. See, now this is the position of the object where the object is in the positive direction, that means in upward direction, upright, and here the image is formed as an inverted. Okay, the image is inverted here. So, and where does the image is formed? The image is formed in between center of curvature and the principal focus of the mirror. So we can conclude that when an object is kept beyond C, and the image will be always formed in between the principal focus and the center of curvature of a concave mirror. Okay, and the image will be inverted, and so the image is also formed on the same side of the mirror. Therefore, the image is a real. And what about the size of the image? The size of the image is smaller than the object. Okay, and if you draw this accurately, if you draw these incident rays and reflected rays accurately, and definitely we can distinguish the size between the object and the image. So we can conclude that when an object is kept beyond C, then the image is formed in between C and F, and the image is inverted and formed on the same side of the mirror. So it is a real image, and the size of the image is smaller than the objects. Then next, when the object is kept at C, F, Now the position of the object is at C. Okay. Now the same way as we did in the previous case, we consider an incident ray which is parallel to the principal axis, which coming from the point B. Okay, this is the incident ray. As we already know, it will reflect back through the point F. Another ray of light which starts from the same point B, which is passing through the principal focus. Then it will be parallel to the principal axis, and we can obtain the image where these two reflected rays are intersect each other. Okay, and if we draw accurately, then these two will intersect at the point here, where that is the point B of the image, that is B dash, and then A dash, B dash will be the height of the image. Now, so now from this figure we can see that when the object is kept at C, then the image is also formed at the same point, and the image is formed on the same side of the mirror and it is inverted. So the image formed by a concave mirror is a real image. And what about the size of the image? The size of the image will be same as that of the object. So we can conclude that when the object is kept at C, then the image formed by a concave mirror is at C itself, and the size of the image is same as that of the object, and then it is a inverted and a real image. And now third case, when the object kept in between C and F. So if the object is kept in between C and F, so where does we obtain the image? So we consider the same rays of light. Okay, one is parallel to the principal axis and another one is passing through the principal focus, and these two rays are going to intersect here, and this is the point where the two reflected rays intersect each other. And since the height of the object is AB, and this point will be the B dash of the object, and this is A dash. So here you can see that the size of the object, first of all, as we know that the image is inverted, it is also formed on the same side of the mirror, therefore it is a real image. And again, what about the size of the image? The size of the image is greater than the object and also inverted. And what is the location of the image? The image is formed beyond C. Okay? When the object is kept in between C and F, the image is formed beyond C. Then next case, when the object is kept at F, when the object is kept at point F, so this is the point where the object is kept. Now we consider the two rays, okay, same A, B. A ray which is parallel to the principal axis, and it will reflect back through the point F, and again another ray of light. So here, second ray of light, we cannot consider a ray of light which is passing through the principal focus in this case, because the object is kept at F itself. Then which ray we can consider here? A ray of light passes through the center of curvature, okay, or another two options, a ray of light which is obliquely incident on the pole. So now we consider another ray of light from the same point which is obliquely incident on the point P, and then it will reflect back like this as per the laws of reflection. What is laws of reflection? Angle of incidence is always equal to angle of reflection. Now here you see these two rays are reflected rays are no longer intersect at any point. For these two reflected rays, they are not even parallel. They are going in two different directions and they diverge from each other. Okay. So where does the image will form? Then the position of the image will be at infinity. So here conclusion is, when the object is kept at F, then the image is formed at infinity. And what about its nature? Since the image also formed on the same side of the mirror, then it will be a real image. Then it is a real image, then it will be inverted. Then what about the size of the image? The size of the image will be much magnified image.